Welcome to our first tutorial video in Chemistry 20. This is chapter 1.1, the Introduction to Science and Technology. But before we even get started into that, we are going to take a look at what is chemistry. Chemistry is a physical science, meaning that it deals with physical things and specifically composition, properties, and changes in matter. We are dealing with physical things, but unlike physics, which deals with how they move and a lot of different chemical equations, we are dealing with the actual matter itself. It's not just about the chemicals, however, it also involves chemical reactions, chemical technologies, and their effects on the environment. We have then this section is called Science and Technology, which leads us to ask the question, what is the difference between science and technology? First of all, science is the study of the natural world. It is knowledge-based only, and it will require technology to make more discoveries. However, technology is the assembly of scientific knowledge. It is outcome or usage based, so it is using the science for something usable, and it requires science to assemble the parts. So we can kind of see technology requires science and science will require technology, so we kind of have this nice circle going around here. Typically, when we think of science, we take a look at the scientific method. We've seen this before. Usually, we've seen this part in terms of the experiments or labs that we have done, usually to test a hypothesis or prediction. We can see several uh, designs or experiments in order to help us understand what is going on within an experiment, but all of this is really just to test a hypothesis or prediction. That scientific process leads us to two different types of knowledge, one built on observation, the other interpretation. Observation is directly from the five senses, but it can also be used, include the use of an instrument. For example, measuring the temperature of a room to be 20 degrees is not directly from your senses, but is using an instrument and your eyesight in order to make that reading. They can also be qualitative or quantitative. Quantitative goes with a number, while qualitative does not have a number. Interpretations are analysis-based and are built upon the observations and are tend to be a lot more detailed than the observations. As we saw here in the analysis section, that's where the interpretation that comes from the scientific process comes in. So another way of looking at two different types of knowledge that can come from that would be empirical or theoretical, where empirical is your observable, such as the observation of color and size of a flame when magnesium burns. Whereas we take a look at theoretical knowledge is kind of more of that uh, interpretation that we saw. So this would be your empirical knowledge, this would be your theoretical knowledge. As we take a look here at magnesium burning, this is a video which shows magnesium burning. We've got this bright white flame with blue. We can see the smoke, and at the end here we see that there is white ash at the end of that video. However, we do not see the atoms actually reacting within there. That would be based on theoretical knowledge. As we take a look at different types of things that come up, we start off with hypotheses, which are built upon various bits of observations, which lead us to generalizations, which then bring us to laws. Hypotheses are small in nature, built on a few different observations, and give us kind of an idea, where we get to then a generalization, which is a lot more encompassing and broad. Laws are usually found to be major concepts for a large body of empirical knowledge, and one of the things about laws is that There's no real distinct uh, breakages of the law that have ever been observed. Definitions are keys to help us understand all that's going on here as they kind of allow us to what's going on. An example of a law would be like the law of conservation of mass, which states that matter cannot be created or destroyed. That should be defined within chemical or physical changes. That does not include nuclear changes, but you get to deal with that in physics class. So for example, here we've got a calcium chloride solution and sodium sulfate solution. They react, we see a reaction, but the mass before and the mass after are exactly identical.